Hi friends, welcome to the Unit 5 Day 5 video. This one's about side angle side similarity. So jumping in now, side angle side similarity, if one angle of one triangle is congruent, remember congruent means the exact same angle, measure, shape, all that, to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. So for this one, I have angle X is congruent to angle M. And so this is I have to use the two sides that include X and M. So I need to use, so XY and XZ are proportional to MN and MP. So notice that this angle X appears, the X has to appear in both of the measurements, sorry, the proportions, excuse me, and M also is in both. So you need to have both parts. Then triangle XYZ is similar to triangle MNP by side angle side similarity. All right. So with that, now we can jump into example 2. So now we want to know if these two triangles are similar. We're just deciding if they are. And then it wants to know the scale factor of triangle A to triangle B. So now we're seeing, when we get done, what the scale factor on this is. And so putting these in a very specific order is going to help us out. Since we know that triangle A is what we're looking at, that's going to be in our numerator for these, where triangle B then is going to be in our denominator. So that's just kind of, knowing that up front is going to be super helpful. So first, the thing to notice is the angle measurements that are the same in both. So for this one, we have 85 degrees, and then this X, the measure of angle X is also 85 degrees. So that's going to be what's going to hold up. That's what's holding up the other two lengths. So I'm going to do this one, this triangle A is going to be in my numerator. So what I do is I usually just make a note off to the side to help remind me that, triangle A is in the numerator, triangle B is in the denominator. So then we're setting it up so that I have, so LJ is proportional. So now this is what we're checking. And so then in the numerator of the other one, I'm going to color code these so it's easier, just like I did with the other video. So we're going to do, this is red. So LJ here. And then for my other one, that's going to be LK. Notice that I used that specific one. And then now, setting this up, I need to make sure that I have these set correctly. So I need L is matching up with X. That means J is matching up with Y. I'll use purple for this. So excuse me. Yeah, J is matching up with Y, so that gives me XY for that one, and then XZ for the other one. So now I just need to check, see if these are proportional, if these reduce to the same value. So LJ is 3, and LK is 4, XY is 12, XZ is 16. So now I'm saying, do these two reduce down to the same thing? 3 goes into 3 and 12, so that's going to be 1/4 equals 1/4. So yes, this is true. So because that's true, then I know that these are similar. So yes, triangle LJK, JKL, you can go in alphabetical order here. Ooh, no, we'll leave it as LJK because we'll see what happens. All right, JK similar to, okay, so that's why I was hesitant. LJK is going to be similar to XYZ, so triangle XYZ. So you got to be careful. This one is not in alphabetical order, but that's what I did. So you just make sure that you got to remember you have to list them in the correct order. Order matters. by side angle side, the scale factor is 1 to 4. And the scale factor, remember, because we set this up correctly in the beginning, the scale factor, so triangle A was our numerator, triangle B was our denominator. So that works. Now we're going to do the same thing with part B, see if that works. So we're going to set it up just like we did with the others. I'm going to do red, and then this dark green. So we've got, let's see. So now it looks like L and Z are going to be our matching ones. So now I've got LJ here and LK here, and that's going to be with ZX and ZY. So now my values, LJ is 9, and LK, oh sorry, LJ is 10, excuse me, LJ is 10. LK is 9, there we go. Right order, Mr. Brumman, come on. ZX is 18, and then 16. Right. These two do not reduce down to be the same. 9/16 can't be reduced. 10/18 can. Let's see, 2 goes in both of that, so that gives me 5/9. And 5/9 is not equal to 9/16. So these are not similar. So then there's no scale factor. So that's for that part. So let's find the value of m that makes these triangles similar when we have, so this is essentially a problem that we don't have the picture for. So we're kind of going backwards. We're saying we want to know what makes this statement true. And so what we need to do is we need to go ahead and make a picture to go with this. Now your picture doesn't have to be 100% perfect. Just get a rough sketch, a rough idea on what it needs to look like. So when I make my picture, I just need to know something like 2 triangles. Okay. And then let's go ahead and go A, B, C, and then D, E, F. So AB is 3, BC is 4, DE is 2m, and EF is m plus 5. And then I know that angle B is congruent to angle E. So I know that those two measurements are the same. So what it wants us to do is it wants to set up the proportion so that this is true. Well, remember when we set up the proportion, we have to set it up so that AB, I'm just going to use it. I'm going to use a different color entirely just to set this up so we can see it. So I have AB over DE is equal to BC over EF. So now when I put in each of these pieces, I have AB, which is 3, over DE, which is, set all those up first, DE, which is 2n, and then BC, which is 4, over EF, which is m plus 5. All right, so I'm going to find the value of m to make this true. So the best way to do this is to cross multiply. So I'm going to take 3 times the m plus 5, set that equal to 4 times the 2m. So 3 times m plus 5, and set that equal to 4 times 2m. So distribute, so I have 3m plus 15 is equal to 8m. So now I'm going to subtract 3m from both sides. 15 equals 5m. So I divide by 5. And I get m equals 3. So the value that makes those two triangles similar is when m equals 3. And then I will save example 6 and then example 8 for our last video, so I will see you there. Have a wonderful day.